A difference of squares is when you multiply two binomials which have the same variable or number, but they have a different sign in the middle. So something like x minus 3 times x plus 3 is considered a difference of squares. The examples we're looking at first are in factored form, and what we'll do is we'll multiply those out to see what they look like as a difference of squares. Pause the video and try multiplying out each of the examples in example 1. So you'll notice what happened on the first one is we ended up with x squared plus 3x minus 3x minus 9, and our two middle terms actually equal 0 when we combine them. So we end up with x squared minus 9. You'll notice that x squared is a perfect square. 9 is also a perfect square. And we have subtraction in there, which is where the difference of squares comes from. Let's try the same thing with the second example. And we end up with something similar. 4x squared minus 25y squared. Whenever you have a set of binomials following this pattern, you'll notice the same thing happens. It also makes it a little more convenient to multiply out because you know your two middle terms are going to end up equaling 0. Now usually to factor, we work in reverse. So we start off with 4x squared minus 25y squared, and we need to look at what we can do to factor that back into our two binomials that are being multiplied together. So when you work in reverse and you factor a difference of squares, to go back to that factored form, you're going to end up with your two binomials that have different signs, and they contain the square root of the first term and the square root of the last term. Let's take a look at what that looks like with these examples. So we can tell by looking at the first one, we have x squared minus 36y squared. X squared is a perfect square. 36y squared is a perfect square. And we're subtracting them, so we do have a difference. So it looks like a difference of squares. What we'd want to do is take the square root of our first term. The square root of x squared is just x. Take the square root of our second term. The square root of 36y squared is 6y. And we would use that to create our binomial, and we would do the same thing again. X and 6y. And following the pattern above, one of these is going to have a plus sign, one of them is going to have a minus sign. Take a minute and multiply that out again and see if it works. X times x will give you x squared. 6y times x gives you 6xy. Negative 6y times x gives you minus 6xy. And 6y times negative 6y gives you minus 36y squared. So when you multiply that out, just to check, it does work out to x squared minus 36y squared. Okay? In the brackets with the two binomials is what we consider our factored form. That's what we're trying to get. If we want to check and make sure our factored form is correct, we can multiply it out again and make sure we end up with what we started with. So why don't you pause the video, try and do the same thing for the second example. A quick reminder of how to take a square root of these because they're a little more complicated. If we have something like 4 over 9m squared and we're taking the square root of that term, we're taking the square root of everything, both the number and the variable it's being multiplied by. So the square root of 4 is 2, the square root of 9 is 3, so we get 2 over 3. The square root of m squared is just m. Similarly, for our second term, you should have 7 over 9 times n. Now you can use these two square roots to set up your two binomials. And we get a similar pattern to before, 2 over 3m plus 7 over 9n times 2 over 3m minus 7 over 9n. And again, you can multiply this out again just to make sure it gets to the right answer when you do multiply it out.